Okay, so this video is for the graph of exponential functions. So for exponential functions, y equal, you have a base 2 to the power x. Right, look like this. If I change the base to 3, y equals 3 to the power x. You see the slope a little bit changed, but it will still go through a point called 0, 1. Okay, I have another function called y equal 10 to the power x. Okay, still goes through this point. Even 100, okay, even 1,000. Okay, no matter what, okay, you can see the differences. From 1, okay, 1 is a horizontal line. Right? 10 to the power x look like the, so maybe just this. Okay, so maybe this is y equals 10 to the power x, and then 100, and then 1,000. Okay, so no matter what, you will go through a point called 0, 1. Okay. But this is when your base is greater than 1. What if it's less than 1? Let's see 0.2, okay, 0.3, or 0.11. Show you the graph, so it will be like a front decreasing, okay, become decreasing from increase. All of these three graphs is decreasing, always decreasing. So the decreasing interval is from negative infinity to infinity. Okay. However, if it's this, the red function, y equals 22 to the power x, that is always increasing. So the increase interval for red function is from negative infinity to infinity. There is no decreasing interval for the red function. Okay, so this is the basic property of exponential function. And then let's have a look at the transformation, right? So we'll go back. Do not do it on the calculator, right? So you go to y. So I want to show you the, okay, make it bigger. So key press history, key press history. So first you press y equals, right? And then, oh, I want to clean this log. So I clean it. Okay. So is maybe 2, all right? And then here, this arrow up, make it exponential, and then x. And then graph. Oh, it goes through 0, 1, right? Yeah. So let's have a look. The transformation, right? The transformation, again, y equals something called b, x, plus or minus. Plus means shift to the left, minus shift to the right. That's in exponential. If it's a constant on the right hand side, plus means going up, minus means going down. So we have to find, okay, let me type. Maybe inside home, I want the Arial, and then I want ET. Okay. So that's to find domain, range, domain range, and behavior, intercept, and asymptote. Okay. Oh, okay. If I have a function called y f of x equal 2 to the power x, domain, so the function look like this. Okay, go through the point, we'll call it 0, 1. Okay. Domain is for x. X can be any value, positive or negative. So domain is all real numbers. Or you can write x You can write from negative infinity to infinity. The range, you can see the whole graph is above x-axis, which means your y-coordinate can only be positive. So I would say the range is y is greater than 0. Cannot be equal. Cannot be equal. Y must greater than 0. Okay. This is end behavior. End behavior, you see the right-hand side is going up. So when x approaching infinity, f of x also approaching infinity. However, when x approaching negative infinity, f of x, it's not approaching negative infinity. F x, the y coordinate approaching 0 because it will get closer to x-axis. So the y coordinate close to 0. This is when your base is greater than 1. If your base is less than 1, between 1 and 0, for example, is f of x, maybe use that color, this, maybe red. Okay. If your function is f of x equal 0.5 to the power x, then the function look like this. Then when x approaching infinity, f of x approaching negative 0, sorry, because this red graph approaching 0 when x getting bigger and bigger. On the other side, the left-hand side, when x approaching negative infinity, f of x approaching infinity. This is when your b between 1 and 0. Okay. Okay, intercept you plug. There's no x-intercept. The graph will not intersect with x-axis. So only y-intercept, which is this point. So y-intercept is 0, 1. Okay. The asymptote usually I said asymptote usually, but not always. Usually is a vertical or horizontal straight line. In this case, the asymptote is this horizontal line we called x-axis. The name x-axis or y equals 0. Okay. So if it's exponential, the asymptote for parent function is y equals 0. If it's for logarithmic function, the asymptote is y equals 0. Okay. It's a vertical straight line. But for exponential function, parent function, the asymptote is y equals 0. Okay, so let's see an example. Maybe question number 7. Question number 7. Please come forward. All right. So you can see there's -2. The -2 exponent means shift to the right 2 unit, and then +3 -3 means shift down. Okay, this -2 is shift to the right 2 unit and -3 shift down 3 unit. So your graph look like this. Before it will go through a point we call 0, 1 because goes to the right 1, 2 unit and going down 3 unit. So go to the point is 2, -2. 2, -2. Right? Because 0 plus 2 is 2. This is for x-axis. For y is 1 minus 3 equal -2. So you must go through the point -2 to -2. Okay. So if you're not sure, use Dasmos help you. Is it 2? Yes. All right. So, oh, finish. So it goes to the point -2, -2, 2, -2. All right, and then let me finish quickly. So the range remains the same. Sorry, domain remain the same. And y, because you shift down, so the y -3. The range for parent function is y greater than 0, but of course, because you shift down 3 units, so the new range is y greater than -3. and then the end behavior, okay, go up, so infinity. The other side, when x approaching negative infinity, y approaching -3 is there. So that will also be the asymptote, right? Okay, the x-intercept, you have to plug in x equals 0, x equals 0. So your y coordinate equals 2, 0 minus 2 minus 3. So that will be 2 to -2 minus 3. That will be a quarter minus 3. That will be 2.75 negative. So this coordinate is is this point. It's 0 and -2.75. That's for y-intercept, and you plug in y equals 0 to find x-intercept. Okay, that's it. I have something to do. Okay, see you next time. Thank you.